Hi everyone, I'm Mr. Baker and this is another physics video. Today we're going to be looking at electric current. Okay, so today we're going to be looking at electric current and we're going to be answering the question, what is electric current? So electric current in a wire, let's look at that first of all. When there is a potential difference across a solid conductor, electrons get repelled from the negative end and attracted to the positive end. So here you can see a circuit. I've got a power supply at the top and you can see that my electrons are being repelled away from the negative end and they're being attracted to the positive end. And this flow of charge in a certain time is called the electric current. Now in physics we have a convention that electric current flows from positive to negative, and let me explain why. So the flow of electric current was first described by Benjamin Franklin in 1750. He assigned two charges, positive and negative, to the excess of charge he discovered in some of his experiments. When the first batteries were made in 1800, the flow of charge was described as going from plus to minus, from positive to negative. And it wasn't until 1897 that J.J. Thomson discovered the electron and realised that it was the thing that flowed and caused the excess negative charge. By this time the convention was set that current flowed in a circuit from positive to negative. So you can see in this diagram that the blue electrons are moving around from the negative end of the power supply to the positive end, and that's as I described it before, that the negative end is repelling away the electrons and they're being attracted round to the positive side. But the convention is set now that electric current flows from positive to negative, so we call the conventional current the flow of charge from plus to minus around a circuit, but the electrons move in the opposite direction. So we say that in solid conductors conventional current flows from positive to negative and electrons flow from negative to positive. So that's okay in solid conductors, but how can we describe electric current in a liquid? Well, in a liquid, ions can move around. Positive ions, we call them cations, are attracted to the negative electrode, the cathode, and negative ions, anions, are attracted to the positive electrode, or anode. And you can see in this diagram that's exactly what's happening. The positive ions are being attracted to the negative electrode and the negative ions are being attracted to the positive anode. So it's the flow of positive charge one way and a flow of negative charge in the opposite direction, which creates the current flow in a liquid. So how do we define electric current then? Electric current is the rate of flow of charge, or the amount of charge flowing past a point in a certain amount of time. The equation for current then is current in amps equals the charge in coulombs divided by the time in seconds. We can put that in symbols. The symbol for current is I because it's from the French intensité of current, and we have the Q for charge because it's the quantity of charge, and then T is time. And you might see that little triangle before the Q and the T. That's a delta symbol, and that just means the change in. So we have current is the change in charge divided by the change in time. Now this is one of the fundamental definitions that you have got to know. You've got to understand this if you're going to understand electricity. Current, potential difference and resistance. If you can understand those three things, then you'll do really well in this topic. But you need to really learn this equation and you need to understand what that definition means. So let's have a look at a little example. So how much charge flows through a filament lamp in 2 minutes if there is a current of 2 amps? So first of all then, write down your quantities. What have you got here? We know that current is 2 amps and we know that time is 2 minutes. We've got to convert that into seconds. So 2 minutes is 120 seconds because there's 60 seconds in every minute. Now we write down our equation. So current equals charge divided by time, and we put in what we know. So we know that current is 2 amps, and we know that time is 120 seconds. So now we've got an equation of 2 equals charge divided by 120. Hopefully we can rearrange that and we get that 2 times 120 equals the charge, and so we have that charge equals 240 coulombs. So this is what you should be able to do by the end of this lesson then. You should be able to define electric current and you should be able to use the equation for electric current. So this is what we've been doing today. We've been looking at electric current. We asked this question at the beginning, what is electric current? And we found out that electric current is the rate of flow of electric charge or it's the amount of charge that flows in a certain time, and we have an equation which is current equals charge divided by time. Okay, so that's been another physics video all about electric current. I've been Mr. Baker, and I'll see you next time.